I didn't see you there. My name's Allie Larkin, and I'm on the set of my new show, Siren Watch, your comprehensive guide to mermaids. In case you're wondering what this is, it's a dry suit because it's still really, really cold out because it's Memorial Day weekend. Stay tuned for my show after the break.
Lost my heart, my home is the ocean, the waves underneath will soon be my home. I will fall asleep, I'll close my eyes and dream of days when I wasn't all alone. All that I know is gone, all that I know is gone. Fall deeper and deeper, the sirens are singing your songs. I'll miss my breath, there's no more left. I'll miss the sound of the wind at my back. The depths have a number, they call you by name. Fall asleep, Davy Jones calls you, so fall asleep and dream. All that I know is gone, all that.
One of the major problems facing mermaidology today is the lack of test subjects. To put together a solid scientific theory, which is a group of hypotheses or a hypothesis that has been supported through scientific testing, in regards to their anatomy, a mermaid test subject must be found. However, the scientific community has been stumped with this dilemma. We don't know where a mermaid would be found, let alone their anatomy. Oh, where would mermaids be found? Would they be in shallow coastal waters or deep ocean trenches? Over 90% of marine life lives in shallow coastal waters like these. So it would make sense that mermaids would live here. This is the most productive part of the ocean because of the large amounts of photosynthetic bacteria and cyanobacteria that live here because of the sun's energy.
I like the gesture.
The ocean covers over 3/4 of our planet's surface. The shallowest waters, which go down to 200 meters deep, is called the epipelagic zone, or sunlit zone. The continental shelf, or the ledge of land that extends from the continents into the ocean before it drops off, is included in this zone. Temperatures range from 52 to 68 degrees Fahrenheit, and the pressure is 20 times greater than at the surface. Phytoplankton produce the majority of the oxygen in this zone. The mesopelagic zone, also known as the twilight zone, ranges from 200 to 1,000 meters deep. The pressure here is 100 times greater than at the surface. The temperatures can range from 39 to 52 degrees because only a small amount of sunlight reaches these depths. Many animals here display bioluminescence, like this jellyfish. The midnight zone, or the bathopelagic zone, is from 1,000 to 4,000 meters deep. The pressure here is 200 times that at the surface. Animals here are smaller than those above and have black, dark brown, or red coloring. Some fish and sea creatures use bioluminescence, and they have long, sharp teeth and large eyes to see their prey in the dark. The abyssopelagic zone, or the abyss, is from 4,000 to 10,000 meters deep. The temperature is close to freezing, and no light reaches these depths. The pressure is 600 times that at the surface. Marine snow, or microscopic flakes of debris from the shallowest waters, is a major source of food. The hydrothermal vents, like this one, are located in this zone. Anywhere deeper than 10,000-ish meters is called the hadopelagic zone, or the trenches. It is the deepest point in the ocean that scientists have found. It is located 7 miles down in the West Pacific. The temperature is 36 degrees and the pressure is over 1,000 times. It is most logical that a merperson's habitat would be located in the sunlit zone. For the sake of discussion, we will assume that the merpeople in question are mammals and not chondrichthyes, or cartilaginous fishes, sharks, and rays. Therefore, their taxonomic ranking would be Eukarya, Animalia, Chordata, Vertebrata, and Mammalia before they diverged from a human taxonomy. Taxonomy, or the academic discipline of categorizing organisms into rankings, began to first gain popularity with Charles Darwin. Darwin, who spearheaded the natural selection part of evolution, also began to identify the species that he studied.
However, we don't know if mermaids would be fish-based or mammal-based, so I'll move on. A merperson's diet would most likely coincide with that of large marine mammals such as dolphins and killer whales. However, mermaids would most likely not be herbivores or organisms that consume only autotrophs because they need an extremely high calorie intake to balance out their high rates of cellular respiration. They need these high rates of cellular respiration to keep fueling their body temperature to keep it in equilibrium with the cold ocean waters. They would most likely consume shellfish, fish, and even other marine mammals. It is important to note that mermaids would be the top predator in the ocean.
The amount of energy passed on from each trophic level is only around 10%, with the rest being lost as heat. So they would need a minimum of 10 pounds of food per day. Atlantic bottlenose dolphins eat anywhere from 15 to 33 pounds per day, to put this in perspective. So, how would mermaids obtain the oxygen needed to use cellular respiration? Well, it is commonly known that dolphins breathe through blowholes. Blowholes are small holes in the dolphin's back that the dolphin breathes through. While underwater, the blowhole is closed by a group of tight muscles. When the dolphin surfaces, the blowhole can empty and refill the lung in 1/5 of a second through an explosive outburst of air. The air introduced from the blowhole is connected to the lungs. Now, this raises the question of how their lungs will work. We can assume that the general structure of the nervous system and respiratory system is the same as other mammals, so the gases they take in would diffuse down a pressure gradient in the lungs, and the oxygen would diffuse into the blood, where it would bind to hemoglobin. Since hemoglobin is the cause of our red blood and therefore pinkish complexion, we can wonder whether mermaids would be the same. Almost all vertebrates use this respiratory pigment, but there are some that use hemocyanin, which uses copper as its oxygen-binding component. This means that blood use is colored bluish. So, would mermaids be cool-toned instead of warm-toned? We can only speculate, but it seems as if mermaids would be closer to humanity in this respect. Speaking of mermaids being close to humanity, their skeletal structure and musculature are very similar. The mermaid's tail was formed from millennia of evolution, where instead of the tailbone receding and becoming a vestigial structure, the tail lengthened and the legs became vestigial structures. Vestigial structures, by the way, are historical remnants of structures that had an important function in their ancestors. So, while the musculature of the upper body would remain mainly the same as humanity's, the tail would have completely different muscles from the lower body of humans. The leg muscles that are present in our legs would wither to form fin-type protrusions on the hips.
Thanks for watching, and remember, the ocean is a dangerous place. Be careful.
That's not bad. How cold is it?
It's pretty cold. I'm not putting my head underneath. Hello there. It's not cold. Going?
Yeah.
I don't like you. Oh. I feel like a fish out of water.
Pulling you out.
No, I jumped in on my own there.
Now I am.